Welcome back. What I want to do today is I want to start a series of videos on sure estimation, seemingly unrelated regressions, and I'm going to separate this into 5 shorter videos. The first one, I'm going to show you how you can get the sure results in Excel. So we're going to go step by step through all the calculations, and then I'm going to create some shorter videos to show you how you can get the results in Stata, SAS, E-views, and SPSS. Now I want to concentrate today on this, on how we can get the results in Excel, because in many cases students do get confused when they see all the definitions of the matrices and all the calculations. For example, when it comes to sure estimation, we have to stack the dependent variable. We also have to stack the independent variables to create a matrix of the following form. And then the size of the X matrix is 2 times T times K1 plus K2, where K1 and K2 are the number of parameters estimated in the first and the second equation, for example. Now this gets quite confusing. So I want to go through step by step how we define X, how we define Y. Also, when we discussed in class what happens when we don't have contemporaneous covariance, in which case our beta estimator collapses to the OLS results, and what happens when we have contemporaneous covariance. And we're not going to go through this in this video. I don't want to confuse you now. We ended up with the following estimator for beta, where we see that we use X, we use the vector Y, and we use W, which we have to estimate from the variances and the covariances of the OLS residuals. Now, all this seems fine, but in most cases, when students see those equations, they do tend to get confused. So I have separated our estimations into 11 steps. In the first step, we're going to estimate the OLS results and obtain the residuals. Then we're going to define matrices X, X transpose, and the Y vector. We're going to create W. And then we're going to go through a number of estimations, which I will try to skip in this video before we get to the results. So let us get started. I'm going to go to the sheet called Solved, and you will have this Excel file available in the website, which I will mention at the end of this video, where you have a solved example, and then you will also have a second example where you can work on step by step. So let's go through this step by step. Let's try to see what we have over here. First of all, let us see what data we have available. We have here 5 observations that I have created from random data. I have 2 dependent variables, variable y1 and y2, and 2 independent variables, variables x1 and variable x2. The system of equations that I want to estimate is the following: y as a function of x1 and x2, and y2 as a function of x2. Now, I have also created up here some links so that you guys can shift easily back and forth on this sheet. So for example, if you want to go to step 8, you're just going to click on this, and it's going to shift you directly down to the results, and then you can click on link back so that you can go step by step through the analysis. So let's get started. The first thing we have to do is estimate OLS. So step 0, estimate the OLS results and obtain the residuals. Now there's numerous ways with which we can do this in Excel, but we're going to do this through the linest command, which is the easiest one. So I have highlighted here an area for the first equation, and I'm going to highlight the area below the definition of the variables, and I'm going to write equal to linest, which stands for linear estimation, and I'm going to add the known y. So for the first equation, the y is y1, and then I need the known x's. So the first equation uses x1 and x2. Let me highlight that, and then I'm simply going to press true and true. And I'm going to hold Control-Shift down and press Enter. So in the results that we get, the constant is 4.5. The beta coefficient for x1 is 0.18, and for x2 is minus 0.14. Let's get the OLS results for the second equation as well. I'm highlighting, and I'm going to write equal to linest. And my known y for the second equation is y2, and my known x for the second equation is only x2. Again, I'm going to close parenthesis, hold Control-Shift down, and press Enter. So now I have my coefficients, which I have highlighted over here for you guys. I can use those in order to obtain the results. So for the first equation, in order for us to get the predicted values, I'm going to write the actual value, which is 5, minus 4.5 minus 0.18, which is the coefficient for x1 times x1, minus 0.14 times the coefficient for x2. Now before I press enter, let me lock the coefficients with F4. And now I can copy paste those values and I have my residuals from the first equation. I can do exactly the same thing. Let me go through that step by step again. So I'm going to write y2 minus 3.94 minus 0.54 times x2, as you can see over here, times x2. Again, I'm going to lock using F4 so I can copy paste this downwards. And now I have my residuals. So the first step is completed. We have estimated the residuals from the first step. Let's go to step number 1. I have defined the previous step as step 0, so this is step number 1. I have to define matrices X, X transpose, and Y. Now in SURE, what we do is we stack the information. So if I had 5 observations from the first equation and 5 from the second equation, in order for me to create the y vector, I'm going to take the first 5 observations, and right below it, I'm going to place the second 5 observations. So as you can see here, I have 6, 9, 6, 2, 8, 6, 9, 6, 2, 8. So the size of the vector is going to be a 10 by 1. Now let's go to X. The X matrix is also going to stack the information. I have already done that here for you. Again, I'm taking 5 observations from the first equation and 5 observations from the second equation. For the first equation, I have alpha 0, alpha 1, and alpha 2, which means that for the estimation of alpha 0, I'm going to need a column of 1s. And then I'm going to need the information from x1 and x2. So over here, you see the information from x1, 73210, and x2, 56532. Same thing for the second equation, a column of 1s for the constant beta 0, and 56532, the information for variable x2. Alright, so I have my y, I have my x. Let me also transpose this. Now I have not completed this, so I can do this together with you, so that you know the command. This is equal to transpose, and then it's asking me for the array that I want to transpose. Close parenthesis, Control Shift, and enter. So what the X transpose matrix does is it takes the first column and it places it in the first row. It takes the second column and it places it in the second row. So I used to have a 10 by 5, 10 rows times 5 columns, and my X transpose is going to be 5 rows times 10 columns. Alright, so I am ready now to go to step number 2. I have defined the matrices. I need to create W. Since I already have X for the estimation of beta and also have Y, now I need my W and my W to the minus 1. So let's go down to this step where we will need to get the estimates of the variances and the covariances from the residuals of the OLS regression. So in order for me to complete the W, I need S1 squared, S2 squared, S21, and S12. Now S21 and S12 are going to be the same, but in order for me to get S1 squared, I have the formula for you guys over here. I need EI transpose times EI. So I need the residuals transposed from the first equation times the residuals from the first equation. In other words, I need this equal to M mult, and I'm going to do it first the complicated way, and I'm going to do it step by step for you guys as well for S2. M mult transpose of the residuals from the first equation. So this is going to be my first array, and then I want to multiply those with the residuals from the first equation. And I'm going to press Control Shift Enter, and I'm going to get a value of 14.58. In order for you to understand what this does, I'm going to do the S2 squared the long way. So I'm going to write equal to 0.63 squared plus 1.83 squared plus minus 0.63 squared plus minus 3.56 squared, and finally plus 2.98 squared. And that's going to get me the value 25.68. So whether you do it the first way or the second way, it is equivalent. It doesn't really matter. To obtain S12, I'm going to write equal to M mult. Now I need the residuals, the transposed residuals from the first equation, transpose times the residuals from the second equation. And I'm going to press Control Shift Enter. Of course, I have to divide this by n minus k, since my n is 10 observations and k is the number of parameters that I'm estimating. I have 1, 2, 3, 4, 5 parameters. I have to divide all of these values by 10 minus 5 equal to 5. So this is equal to 14 divided by 5. And I can copy paste this across so I can get the results. All right, so I have my estimates for S1 squared and S12 and S2 squared. So now that we have the information, we can go ahead and create the W matrix. And as you can see here, you have the Kronecker product. And I'm going to place the value 2.91, that's S1 squared times IT, on the main diagonal of this block matrix. So this is going to be plus 2.91. And again, I'm going to place this value 5.13 on the main diagonal. And then I'm going to use S12 values for the main diagonal of S12 times I, and finally the same value for S21 times IT. So I'm done here. I have created the W matrix. Now I need to invert this. So I'm making this a little bit smaller so that you can see what I'm doing on the same screen. So I'm going to invert this, and I need another 10 by 10 area. So I'm highlighting a 10 by 10 area, and this is equal to M inverse. And I'm going to choose W, close parenthesis, and press Control Shift Enter. So now I have my W to the minus 1, I have my X transpose, my X and my Y, and I can go ahead and do all the necessary calculations using the M mult for matrix multiplication. Now I'm not going to go through all steps 4 through 7 or through 8 because it's going to get quite tiring and it's going to get confusing, and I'm going to let you guys see them. I'm just going to go through this one matrix so that you can see how this is done. In this next step, I want to try to create X transpose times W to the minus 1. I know that my X transpose is a 5 by 10, and my W to the minus 1 is a 10 by 10. That means that I can multiply them since the inner product is the same, and the outcome is going to be a 5 by 10 matrix. So in order for me to get the results, let me erase this. So I'm going to highlight an area that is 5 by 10, and I'm going to write equal to M mult for matrix multiplication. And my first array is going to be a 5 by 10, the X transpose. So let me go upwards to find my X transpose matrix. There it is. And I'm going to put my semicolon or comma, depending on what your computer, what your version of Word of Office does. And then I need to put my W to the minus 1 matrix. So I'm going to choose this, close parenthesis, and press Control Shift, hold it down, and press Enter. And my results for the X transpose W to the minus 1 matrix are as follows. Now I can go ahead and show you the rest of the steps, but I will not because I'm going to have to do a lot of shifting back and forth, and that's going to get confusing. But you can always click on any of those cells in order to see the formula up there so that you can understand what it is that we're multiplying. So for example, over here, I'm multiplying the X transpose W to the minus 1 matrix. That means this matrix, which is a 5 by 10 matrix, and I have written this out step by step for you, with the X matrix, which is a 10 by 5. So it's taking the information from E15 to I24. So I've done this already for you. So let's go directly to the results. and I'm going to go directly to step number 9. So after the final multiplication, I have highlighted over here for you the results that we get from the OLS and the results that we get from SURE. Now, these are the results that I got from Stata, which we will do in the next video. I want to show you that the results that we got earlier from the OLS are different from the results that we got from the SURE model. So these results over here are the ones that we got earlier with the linest command. And these results over here are the results of this beta estimator, which yield the 5 by 1 vector. So this is going to be the constant for the first equation. 0.23 is going to be the coefficient for x1, and 0.304 is going to be the coefficient for x2. And as you can see over here, these two are different, and these ones are also different. Now let me just make one more note before I go to the standard errors. If there is no contemporaneous covariance, I'm going to go back to the definition of my WI matrix. If there is no contemporaneous covariance, then my S12 and my S21 are equal to 0. That means that I can replace this with 0. The main diagonals of S21 times I and S12 times I, I'm replacing them with 0, which now means that my results should be equal to the OLS results. So let's go and see if our results have changed. As you can see now, our results are the same as the OLS results. So when there is no contemporaneous covariance, the OLS results and the SURE results are exactly the same. Let us change this again so we can estimate now the standard errors. In order to get the standard errors for SURE, I'm going to take the main diagonal, which is 5.36 for the coefficient of y1 equation, 0.05, 0.27, 941, and so forth. And I am simply going to take the square root of those values, and those are my standard errors. So these are our results. For the first equation, our beta 0 is 4.21 with a standard error of 2.31. For beta 1, 0.023 and 0.07. And again, for the second equation, our beta coefficients and the standard errors. Now, I try to keep this as simple as I can. I didn't want to shift back and forth all the time. So what you guys have to do now is two things. The first one is you have to make sure that you understand each one of those steps. In other words, how I get to step 4, how I get to step 5. And then once you do that, I have created a different set of data on the worksheet that is called Work on This, where I have kept all the highlights, and you can use the information that I have on Solved in order to replicate your results. In the next couple of videos, what I will do is I'm going to replicate those results that we got here via Excel so that you can see how we can obtain them through Stata, SAS, E-views, and SPSS. I hope this clarifies the estimation process for SURE. So work on the problems and watch the next videos. Thank you very much.